Okay everybody, I'm back here at the Sebastian Nature Trail yet again. I'm actually standing right on top of the well, the piezometer that we installed 2 weeks ago. And I'm here because we're going to use this piezometer this week as part of a groundwater velocity calculation. So the whole entire purpose of this week's lab is to calculate groundwater velocity at the Sebastian Nature Trail and figure out how long it's going to take groundwater to move from this well over to the nearest surface water body, which is that pond behind me. So we're going to be talking about how to calculate the hydraulic gradient. You guys have already calculated the hydraulic conductivity in two different ways. You use the Hazen formula, the D10 from the grain size analysis. You also, last week, you did a slug test. That'll give you hydraulic conductivity. And we're also going to talk about how to measure the porosity. So those are the three things that we need to calculate the seepage velocity. Remember, seepage velocity is equal to negative K divided by porosity times DH over DL, okay? So what I'm doing out here in the nature trail today is I'm getting us set up to be able to determine the DH over DL, or what we would call the hydraulic gradient, okay? So the hydraulic gradient would be the change in hydraulic head divided by the length. So it's a slope, in other words, it's a rise over run. So one of the ways that we can get DHGL is we can actually contour the water table, and you guys have done this before, you did that a few labs ago. But another way that's used quite a bit is to fit a plane, a three-dimensional surface, in other words, to three known water table elevation points. We call this method the three-point problem, and it's analogous to fitting a line between 2 points. Here we can fit a plane to 3 points. So I'm going to use the well that we just installed here, which, by the way, I'm going to call this PZ19. It's official now. And I'm going to use two other wells that are just behind me. I've got PZ11 over here. I've got PZ12 over there. So those will be my three wells. Now, we're not done with PZ19 right here. It needs a little bit of work. I'm gonna have to get the top of casing elevation. That's why I have all this equipment with me here. I have some survey equipment. But before I survey this in and put all the hard work into surveying that top of casing elevation, I want to lift this thing up a little bit, okay? We're gonna have this thing here for the long haul and be here for many years of enjoyment. And right now it's too low to the ground. This thing's gonna get lost. So let's go ahead and fix that. First thing that I'm gonna do is I'm gonna flag this. It took me about 5 minutes of wandering around the woods before I was able to find this well today. So that's gonna help out a little bit. But what's probably gonna help out a lot more is I mentioned in the well installation video that we could attach a riser to this and we could rise this well up. So I've got simple components needed to do that. I've got a PVC coupling right here. This is 1 1/4 inch. And I've got another length of 1 1/4 inch PVC pipe. This coupling will then allow me to rise this well up. So in order to do that, I'm going to use a little bit of PVC cement. And we'll have this thing ready to go, again, ready for the long haul. We'll survey it in, we'll get depth to water for this well along with the other piezometers behind me. We'll have 3 water table elevations, we'll have 3 known points, and I'll show you guys how we can solve the 3-point problem and calculate the gradient. Okay, so let me get set up to cement this together. Okay, so I've got everything just about ready to glue this coupling onto the top of our casing and to put this riser on there. Again, I want this well to last, so the way that I'm going to do this is I'm actually going to use a little bit of PVC cement. So if you've ever used this stuff before, you know how useful it can be for fixing plumbing, maybe in your house or something like that. And this is going to set this well up to last. So I've got 2 components here. I've got PVC primer. This is the purple stuff. This stuff will stain anything it comes into contact with, so I got to be kind of careful here. I don't want to be purple for the next couple days. And I'm going to put some of this primer around the outside of our well here. Let's give it a nice clean. This is going to get a nice bonding surface for our PVC cement. And I'll put it around the outside. Here we go. The outside of our riser. Okay, so that's all set up. I'm going to very carefully screw this back together. Trying not to get the purple stuff on me. This nice and tight, some channel locks, make sure it doesn't spill in my wife's car either. It's a good idea. And then I've got some PVC cement here for us. So the cement will go on the inside of our coupling, our PVC coupling here. So I'm going to go ahead and put this around the inside, nice thick layer, built to last. Nice thick layer over here. This stuff dries fairly quickly, so you want to get everything kind of arranged before you start gooping everything up. And we just slide this on. There we go. And then slide the riser on top. There we go. So the well is now extended probably out of the frame here. So let me zoom out and we'll finish this well off. All right, so I had to rise the camera up a little bit. This is going to be easy to find. Actually, this might be a little bit too high, but that's okay. We'll live with it. I wanted to stand out since it's out here in the woods. I want people to be able to find it in the future very easily. Now, last thing we need to do before we survey this thing is you can tell it's a little bit crooked. So that means the top of this casing here, even though I cut it with a miter saw, it's nice and flush with the PVC. It's perpendicular to the PVC. Since it's tilted a little bit, I want to make sure I've got a nice reference that I'm going to survey in. So again, we always try to use the north side of the well. That's just standard convention that hydrologists use. I like to mark mine with Sharpie, so that way if somebody else is using it, they can find that north side really quickly. But if you're ever working on the job, if you're working with wells, if you're gauging wells, and somebody didn't leave you a Sharpie mark, then just assume that you use the north side. So I'm going to use my compass to make this somewhat precise. And since I'm in the middle of the woods, it's a little bit harder to find north, but here we go, just about there. So I've got north azimuth, and I'll just Sharpie it in here. Okay, so this well is just about done. Last thing I want to do is label it PZ19. So this one will go down in the history books as being maybe one of the most unusual wells that we've had to install as a class. But you guys are part of it. This is your well. Again, come out and visit it anytime you get a chance. It'll be waiting for us. So the next thing that I want to do is I want to survey in this well. The other wells and piezometers have been surveyed in. So your TA, Zach Peoples, and myself, we actually worked with surveying equipment and surveyed in everything. It was a little bit of work. So to add an additional well to that survey data, to be able to survey in this well, in other words, it's going to be a lot easier. So the method that we're going to use to survey this well is we're going to use some pretty sophisticated surveying equipment here. This is the industry standard for surveying. We're going to use a device here called a total station. And a total station combines two types of measurements together. It makes angular measurements, so you get a horizontal angle. It has vertical angular measurements as well. And it also, inside of it, it has a laser, it's basically an infrared laser distance finder. So by getting the angle, the horizontal angle, the vertical angle, and the distance, you can determine basically positioning from one object to another object. Now, the thing about the total station is that this isn't like a GPS in the sense that I can just set it up and this instrument is going to know where it is. It measures everything relative to its own position. So in order to use a total station, you need to let it solve for where it's set up. So to do that, there's two major ways that we can get this thing kind of settled into its position. One is you can set it up over a known position, and then it knows where it is, but it may not know where it's facing, so you need to shoot to one point, and that will let it know which way it's facing, which way north is, in other words. That's called backsighting, where you set up on a known point and you shoot back, you sight back, in other words, to a known point. That will do it. The other way is that we can do what's called resectioning. And resectioning will set this thing up on an unknown point, and we shoot to two known points. What that's essentially going to do is it's going to create two lines. It's going to create two lines, one from the instrument to one known point, one from the instrument to a second known point, and where those two lines intersect, that can be solved for using simple trigonometry, and the instrument does all of that for us, so you don't have to worry about the trig. That's going to allow it to solve for its own position as well. So fortunately, I've set this thing up in line of sight. This well is here in line of sight of piezometer number 11, which is to my right, to your left, and piezometer number 12, which is behind my left shoulder, so over there to the right a little bit. You might be able to see it, I'm not entirely sure. So we will resection off of those two wells. So next thing I'm going to do, I'm going to get the instrument all set up. I'll probably put a fast forward on this so you can see how it goes together. Those of you guys that have had geomorphology before, you're very familiar with the total station. Some of the engineers have maybe had surveying before. I don't know if it's a class that you're supposed to take or not. So I'll show you how the total station is put together. If you haven't seen it before, it's kind of interesting. All this really requires is a lot of tripods. So give me a second to get all that set up, and I'll see you shortly.
Walk with a light step, baby. Catch a breezy. Live amongst the life forms in your day. Marinate a good piece of beef. Understand the mind of a leaf. Swim around till the fish float out of the socket in your skull. Dive deeper, corner all the fungus in your brain. Take it easy, I wanna live your life in vain. Mope and shoot things or leave them to rot. Woke up with a nose full of snot. Baked the muffin, the top's burned and I had to throw them away. Up this morning, a lot sooner than I thought. The sun was shining, plucked a flower from the stalk. Smelled good and it made me smile, so I took a run about a quarter of a mile. Felt my lungs fail, so I got myself back home. Take it easy, walk with a light step, baby. Catch a breezy, live amongst the life forms in your day. Marinate a good piece of beef. Understand the mind of a leaf. Swim fish float out of the socket in your skull.
Okay, so now that the instrument is all set up, it's resectioned, it knows where it is, it knows where it's looking, I can now shoot to an unknown point. And I'm going to shoot to the top of casing for PZ19. So you might be able to see, I've got the target already set up right behind the total station. Total station's ready to go. The only thing I need to do at this point is I just need to select a measurement. And this will do the rest. So hit measure. We're going to call this one not PZ15. We're going to skip and call it PZ19. Hit measure. Here it goes. And there we go. So it's now been recorded. PZ19 is now saved inside of the memory. I'm actually going to go ahead and write down the information just in case I don't want to take this back to my office and download it. And so I'll share top of casing elevation for PZ19 with you. Also going to share top casing elevation for PZ11 and PZ12 with you. Now the only thing that we have left is we need to get depth to water. If we get depth to water, that's going to allow us to transform the depth to water measurements, top casing elevations into water table elevations. Never gets old using one of these. We got our nice fancy north mark, that's where we surveyed, PZ19. So down the well we go. Listen to that. So that puts us at 10.85 feet. 10.85 feet for PZ19. Okay, so now depth to water at PZ11 here. We measured it 2 weeks ago, or 3 weeks ago actually, but it's probably changed. So let's get the most recent depth to water. So that's 8.92 feet. And now time to get PZ12. Okay, here at PZ12. So that is 6.12. Okay, so we got depth to water for all 3 of our wells. We got top of casing elevation for all 3 of our wells. Now it's time to put all that data together in the 3-point problem. But before I do that, we're actually going to go back to the lab and we're going to get the data that we need to be able to calculate porosity. So stay tuned for that.